Very good afternoon, sir. Our convener, ma'am, Ms. Sindhu Chaudhary, and our and Suresh, sir, who has organized this event. Our today's uh, so today, Mr. Varun Agrawal, sir, has taken out time from his busy schedule to take this session for us. The session being on career prospects in data analytics. I'll give a brief introduction about Sir. Sir is an alumnus of Delhi School of Economics and has over 14 years of experience in consulting in advanced analytics. He has solved complex problems for Fortune 500 companies across banking, telecom, and utility sectors. Currently, Sir is serving as the Vice President at EXL Analytics, leading a team of 150 plus data scientists. Sir has pioneered research on machine learning at EXL a decade ago, and he has led a team of 20 data scientists to win Heritage Health Prize competition, securing second position among 1,600 plus participating teams globally. Sir has also authored 8 research papers in the field of predictive modeling presented at various international data analytics conferences. Sir has innovated several model development tools such as hill climbing algorithm, super interaction segmentation recommender, feature clustering enhancer, and media mix optimizer, to name a few. Thank you, sir, for taking this session. We welcome you on behalf of Placement, sir.
Thank you. Thank you, everyone.
Hi, Varun. On behalf of Placement Cell Kalindi College, I extend a warm welcome to you. And we are looking forward to your session eagerly because I think data analytics is a very hot topic, hot career option these days. So I also, being from economics department, I'm also looking forward to your presentation. Welcome once again.
Thank you, ma'am, for the warm welcome. Really appreciate it. And thank you for inviting me for this session. It's a pleasure being a part of it, given I'm getting a chance to interact with the youth of the country. And I'm hoping that after this session, people will have better understanding of in which direction they should go if they want to go for data analytics. So
yes, absolutely.
Thank you. Without much ado now, let's move to the presentation. Suresh, I'll request you to control the screen and if you can just move to the next. Okay, so first of all, let me try to explain what is data analytics. So many times we get confused by the term analytics, and it's actually getting utilized in various forms and shapes. So it will be beneficial for us if we can take a step back and try to understand the meaning of the same. So it's all about understanding patterns in data in a systematic way to make decisions. And all the things that we have highlighted here, understanding patterns, data, systematic way, and make decisions, are very crucial, important. So if you look at data, so data can be of multiple forms and shapes. It could be structured data, unstructured data. So structured data example is a simple table. Like, let's say you look at the data of a bank. You have customer information, their transactions, and bunch of features relating to the customer, relating to the each and every transaction, the bureau data, the bank's personal data, right? But that will be all in a very well formatted form, in a tabular form where you will have rows and columns. On the other hand, the unstructured data can be of any, again, form. It can be text data, let's say medical prescriptions. So now the healthcare industry is also utilizing it big time to understand the different patterns and recommend solutions for the same. It could be image. So for example, let's say we talk about insurance industry. So for I would say processing the claims, accident claims, there will be a need to analyze the images. Or even in the healthcare industry, you will see the images get analyzed a lot uh, to make sense out of it, and then make progress on the research. So that is again the different form of data. When you have text, image, even the audio data, video data is there. So many times we see in call centers, the video recording is analyzed to understand what the problem of the customer is. And if you do it manually, it is going to take a lot of time. Hence, there are algorithms that can analyze audio information and create some meaningful insights out of it. And similarly, on video side, videos are taken now every second. Even at airport, when you have a lot of video recording for monitoring, that data is utilized to analyze information. So as we understand, the data is in different forms and shapes. So it is important to first of all understand how the data is to be processed before we analyze it. The second important part here is understanding patterns. So you have now plethora of data. So it's a task to even read that amount of data and then to make sense out of it. So there are a lot of visualization tools these days which can be utilized to summarize information, to visualize it, and to generate insights as well. And then there can be customized way of doing it, where basically we write algorithms, we try to understand how different characteristics of data can be correlated with each other, and then you draw some insights which can be communicated to the business teams to make meaningful decisions. And that leads to the third part, which is making decisions. So whatever analysis we are doing, at the end of it, it has a purpose. So we need to also define the goal, the objective, why we are doing the analysis. And I will come to it later, like what kind of decisions we can make. And the last part is the systematic way. It is also important. It's not going to be done in an ad hoc manner. You have to ensure that whenever you analyze information, it is reproducible in a meaningful way, so that the solutions can be generalized. They can be utilized on new data sets, new customer base, I would say a new set of information, so that you can score the algorithm on your actual database. So the systematic way is also pretty important, and it will involve usage of right algorithms from statistics field as well as from computer science to generate insights. So I hope that clarifies what data analytics is before we get deeper into it. If there are any questions, please let me know. I'll take a quick pause here.
Yeah, Varun, I think in the end, we are going to have a question and answer session.
Okay.
Okay, you continue. Yeah.
Okay, understood. So we'll do it later. Okay, let's move to the next page. Now here we are talking about the prerequisites. So we looked at data, understanding patterns, making decisions. Now for each of these stages, when you process data, the primary skill that we need is for extracting data and engineering it. So data extraction is an art. I mean, we cannot just read everything and process it. So there has to be a way to understand what my missing values are, where are my outliers, so that I can treat them. Should I do missing value first, missing value imputation first, or should I do outlier treatment first? So that is also a sequence that we need to take care of before we process the information. The second part is data engineering. So when we look at the data, we get the raw variables, but we can also apply feature engineering on top of it to add more important, or I would say derived variables. So for example, if you have information on say distance, and then you have time, then you can calculate speed, and you can use speed as one of the variables. So this is just one example where one variable is derived from the other. There can also be a possibility where you have nonlinearity in your data and you would want to do some transformations. For example, let's say we try to analyze how experience and compensations are related to each other. Now, as we move from 1 year of experience to say 2 years of experience and to 3 years of experience and so on, the compensation also increases uh, ideally. Now, in that situation, we see that both do not increase in the same proportion. There can be some kind of a function, some kind of a relationship between the two. And we typically see that the compensation could be square of what we see as number of years. So in that case, a square transformation may be useful. Similarly, when we try to analyze, say, the population density, maybe log transformation can be more useful. So we can apply different transformations, and that will also depend on the objective of the study. The second important part here is understanding patterns. Now, for understanding patterns, the skill set that we need is domain knowledge, because we need to apply that business sense before we start jumping to the conclusion. Here, data visualization is also important because that helps you understand the data faster and also gives you a way to communicate your results to others. The third important thing here is statistical techniques. So when you summarize the data, you get to see what the overall trend is. However, you also need to uh, apply the right technique so that you can take a call whether I'm going to do optimization, or I'm going to do prediction forecasting, or I'm going to just simply create some policy rules by doing crosstabs. So, what statistical techniques is applicable is also a function of your objective function, uh, and is also a function of what you want to basically communicate to your client or to your organization. The third important part here is making decisions. Now, for making decisions, it's very critical. Sometimes people say that okay, we don't need hands-on experience to to make decisions, but I don't believe that is right. In fact, I feel that if you do things hands on, you will get more, I would say, understanding of how much time it takes, what kind of challenges you're going to face. And there, gradually, you also develop a lot of experience in taking decisions. So, here, logical reasoning is going to be extremely, extremely important. If you are able to do, say, cost benefit analysis, you would be able to take a call how to prioritize, what to prioritize. And secondly, here, result orientation is extremely important. So whatever insights we generate, if those cannot be translated into actionable items, those insights will be meaningless. So hence, whosoever is making the final decision has he or she has to also think from the business standpoint, that where we are going to apply it, what are the practical challenges of doing it, and eventually what is the benefit that an organization is going to achieve after applying these insights. Lastly, communication skills. So it's very common. So data scientists are typically known for writing great algorithms or getting too much into data, and at times they lack that skill of communicating their insights. Hence, it is important to side by side also develop communication skills. And by communication, I do not mean just verbal communication. It also means how you are presenting your outcomes, say how you're putting it in a PPT form, or how you're visualizing your data and communicating the summaries. So that is important. And then you also need to highlight the part where you can show what's the benefit of applying this solution and what are the drawbacks of it. So what are the areas where the solution is not going to be applied, so that eventually you do not end up applying this solution as a brute force method and apply it everywhere and then face losses. So here communication is going to be extremely important for making decisions. Now, with these prerequisites in mind, let's move forward and try to understand what else is required when we get into data analytics. So, Suresh, can you move? Yeah. So here we are looking at the different gates through which we can enter into the field of analytics. So, as I mentioned before, domain knowledge is important. So, domain specifically here means business sense, right? So, let's say someone has done MBA and has also spent some time in a specific industry. That person is expected to do a lot better in on the business side, and that person probably would have that kind of edge over others while applying the business sense. So hence that person probably would need to spend more time on understanding the statistics and technology, so that eventually that individual becomes more, I would say, knowledgeable, and eventually move towards the path of analytics leader. And the other field here is statistics, which is going to be the core of the solution. So whatever technique you apply, be it even sampling, right? If you do not do the sampling of your data rightly, everything will go in the wrong direction. So right from the beginning, when you are choosing your data set, uh, and then to the final point where you're communicating your insights, uh, statistics needs to be applied in the right way. uh, a simple example what I have seen, when there are classification kind of problems, you do not look at r square, right? You look at what is the misclassification cost. Are you classifying an event as event only or non-event? However, when you are predicting a value, then you would look at the relationship between the predicted and actual. How is my predicted value differing from my actual? What's the magnitude? So there, these are some basic things, but of course, as you grow further into the advanced value chain of analytics, you would see that application of statistic is a must-have, and you don't need to be a statistical expert. By the way, you can also gain that knowledge on the job. The third important wing of this work stream is technology. So in technology, it has to do with data understanding, reading, also uh, coding. So where you can do the right kind of programming for efficient data processing. And finally, there can be technologies related to, let's say, big data platforms, or say deploying your solutions on the cloud platforms. So these are some emerging fields where technology plays an important role. So there are certain section of people who come from technology background, and they do very well as an analytics leader in the long run, because they acquire domain knowledge and statistical knowledge over time. So no matter what is your area of strength today, you need to also start looking at the other fields as well, so that eventually when you become an analytics leader, you become a more balanced person as an analytics leader and can take right decisions. And let's say if you do not have these you do not have domain knowledge, statistics knowledge, and technology knowledge even today, then you know that what are the different areas from where you need to start. So as a fresher, I don't expect that people would have any understanding. But given your background, let's say from economics or statistics, probably you can start from statistics and start also delving into technology and domain areas. Okay, so let's move to the next page. Okay, so this is basically to uh, walk you through what are some myths and realities, so that you do not jump to the conclusions right away. So the very first one is analytics can't solve business problem. Of course, that is not true. Analytics can be applied to solve business problems, but if someone tells you that analytics can solve all problems, that is also not the right statement. There would be some areas where analytics will not have any role to play, and you would have to take decisions based on uh, basically for, let's say, for the social welfare. Also, for example, let's say you have to make decisions based on the given constraints that you have, or say government regulations. So you cannot apply analytics everywhere to solve all kind of problems. So you need to make sure that you do not end up overusing it. Second important part here is, sometimes people say that analytics has nothing to do with statistics. We can do some courses from here and there, and statistics can be learned later on. Again, that is not true. It has to do with statistics. You need to know some basic concepts so that your foundations are correctly built. But if anyone says that it's all about statistics, that is also not right. So there is a lot of, it's a combination of multiple things. Econometric statistics is one part of it. Computer science is second. Then you also need to uh, apply operational research kind of knowledge at times, depending on the problem statement. But it's not just statistics. Now, the third point here is analytics does not require data. Of course, it's not right, because the very first definition of analytics is we have to understand patterns in data. Right? So definitely it requires data. But if someone says that analytics requires huge volume of data, that is also not right. So let's say you are analyzing, say, 100 resumes, right? And then 100 resumes are enough to make a decision to take a call. Or you have a bunch of invoices, say 500 invoices, and you analyze them and then try to draw some insights. So so analytics can be applied on 100 or 500 records also. You do not need millions and billions of data. It depends what problem you're trying to solve. If you are trying to solve a problem for a bank, then you would see there are millions of customers. Their transactions may go into billions. If you look at, say, number of social media comments, they can be in billions. So different analytical problems may have different volume of data. So don't get, I would say, influenced by these sayings that analytics require huge volume of data. The next part is simple analytics models are always better. Of course, that is not right. The more you uh, create your solution sophisticated and elegant, and better it is going to be. But this is also not true that complex analytics models are always better. The reason being, we also need to keep in mind how these models are going to be interpreted, how they are going to be eventually applied. Right? So, hence, complexity does not always rely in the number of layers in a neural network, right, or number of variables in a model equation. So complexity also also lies in deploying that solution. So hence we need to ensure that the analytical models, that whatever we are creating, they should be deployable, they should be real, right? Sometimes the infrastructure may not be that solid to implement a very complicated model. Lastly, a good model increases error in decision making. That is not true. A good model is supposed to reduce the errors. But if it is all about minimizing error, that is also not right. And in analytics, when you make a statistical model, there is a concept of train and test data set, right? Where on train data set we try to build the models, and on test data set we try to validate it. And it's also very important that the models can be generalized. So whatever we are building on train data set, if you are getting very different results on test data set, then your model is not stable. So it's not about minimizing errors on your training dataset. It's also about whether this model can be generalized. Is it robust enough to get implemented on a new data set, something which is going to be real? So just to give you an example, if you build a model, how many people are going to get placed based on, say, last 2 years of data, right? And then you also apply the condition of COVID, right? So then the result may be different than what you're going to have in next 2 years. So you cannot just simply apply that model everywhere. You have to also test it out and then see whether this model is good enough for application in reality. Okay, so the takeaway here is that we always need to strike a balance before we jump to any conclusion. So don't get influenced by such extreme statements that analytics can do everything or it can't do anything. So that's my message to you on this page. Let's move to the next one. Okay, so here the idea is to give you an example or some examples what kind of decisions we make. So you remember we mentioned understanding data patterns in a systematic way to make decisions. Now, what kind of decisions are we talking about? So example could be growing the business. So let's say a retail outlet comes to you and tells you that my sales are going down, or I'm not getting good business. Can you help me out? So you need to understand what is the reason behind that. What is causing a drop in sale, or why the sales are restricted? So that particular problem statement will be more about solving how to grow the business. The second important objective that we typically see in real life is improving efficiency. Let's say a manufacturing unit comes to you and then says that my process is not efficient enough. Can you analyze whatever my current process is and give me recommendation how I can improve it? So that is also an analytical project. It could be improving efficiency in the process of say processing, say, claims. So you have a bunch of claims, and they keep on moving from one desk to other. How you can improve the process? How can you make it more efficient? So that will also be an analytical problem. The third important objective that we typically see is how to target customers when you're launching a new product. It could be a new product, it could be a new market. Then how to go into that market, how to sell or introduce a new product. So that is a customer acquisition strategy that data scientists need to recommend. Fourth important part is customer experience. It is primarily used when we want to retain the customers. So let's say you have a bunch of customers, let's say with a telecom company, and customer base is in millions, and of course they cannot uh, help each and every customer. Then you will have to apply analytics at scale to ensure that all the customers are getting right attention, so the customer experience is good enough and they can be retained and they do not port their numbers to a different company. Last one is mitigating losses, and these are mostly driven by regulations. If you do not follow a particular regulation, a particular organization may get penalized, and then some analysis will be required around it. Or it could be, for example, fraud detection, right? So if there are frauds on, say, credit card, and if banks do not apply right analytics to prevent fraud, then there will be losses. So here the objective is not to grow the business, but to protect whatever revenue they have. So these are some examples, and these are real problems, and hence the analytics helps in solving all of these. Uh, so Suresh, let's move to the next page. Okay, here on this page, we are talking about the kind of problems that we typically see in analytics projects. So the previous page was more from, I would say, a business owner standpoint, like what are the problems they face and they want a consultant or an analyst to solve. And these are from the point of view of a solution provider, right? That if I need to provide a solution, what exactly I'm trying to do. So first one is estimating a value, right? Which means you are trying to estimate particular number. It could be, say, sales number, profit number over next few quarters. An example here is, you are, let's say, working for an insurance company and you need to look at the premium that should be charged for each and every policy holder. So in this case, you're going to estimate the value based on certain characteristics, estimate the value of premium. The second problem statement is predicting a category. So it is more like classification problem, and the classification could be, say, binary, yes or no, or it could be multi-category. Right? An example here is, okay, if when a particular individual is swiping the card, the bank needs to make a decision instantly whether I should approve or decline the transaction, and they decline the transaction when they suspect fraud or when there is insufficient balance. So you need to predict yes or no, right? So that is the kind of problem statement you may come across with. The third important problem statement is identifying the segments. So here you need to look at the customer base, how you can divide them into different groups which are homogeneous within them and heterogeneous across. So there you need to ensure that these groups can have separate or customized target strategy. The fourth important problem statement that we see is discovering the association, which means that how one thing is related to the other. So on a particular e-commerce website, you would see that when you buy a product, you get a recommendation that people who bought this also bought that. So this is nothing but a recommendation-based engine, and hence they are basically using collaborative filtering or some other algorithm to make that recommendation. So that comes under discovering the association. The fifth kind of problem statement that we typically see is forecasting a time series, where you're again estimating the value, but over time. So let's say what is going to be the customer care volume every hour, or what is going to be, say, losses of a particular bank every quarter. So that kind of a problem is like forecasting problem. And if you, I mean, some of you have read statistics or economics, you would have seen methodologies like ARIMA, Holt Winter. So those are used for forecasting a series. The next one is optimizing allocation. So here it is more about optimizing the given resources for the given constraints, right? Subject to given constraints. So a particular example could be, let's say you have a budget given to market for smartphones, and then you need to take a decision whether I should do a TV ad, or whether I should send emails, whether I should print, whether I should do out of home advertisement. So all those decisions are not very easy to make, because then you need to also look at the return on investment. So hence there you need to do some optimization based on given constraints. So these are certain examples of the problem statements that you would end up solving if you get into the field of analytics. Okay. uh, okay, let's move to the next page. Okay, so this one is again interesting. So this gives you the full spectrum of analytics, right? So initially, I mean, until some time back, there used to be four types of analytics, but now the fifth one has been added, and let me walk you through the entire chain. So on the x-axis, you see business value. On y-axis, you see complexity. As we move from descriptive to diagnostic to finally cognitive analytics, business value as well as the complexity increases. So descriptive analytics is like you try to understand what happened, right? And let's take an example of a telecom company which is losing its customers, right? And they are just coming to you as, I mean, they are hiring you as a consultant, and they want you to analyze what is happening with their business, why it is not growing. And then you see, okay, probably it is because customers are leaving. So you create some reports, you analyze the data, and then you figure out that it is because the customers are leaving. Now the second question comes: why did it happen? Why are they leaving? So then you need to find the root cause, and then that's where you need to apply the diagnostic analytics. The next question comes: okay, whatever happened has happened, but what can I do for it in future? Like, what will happen in future? Uh, who is going to leave? Who's going to get retained? So then you start building statistical model which will give you probability of say staying back with the organization or leaving. And then it will be like a classification problem where you will build a statistical model. Now once they have the probability of leaving or staying back for every single subscriber, the question will be that what should I do about it? Now I know the math, I know that there is some number, zero point 0.9, zero point 0.7, zero point 0.8, but what do I do with it? So then you need to also recommend some actions. So if we're talking about, say, telecom company, maybe you recommend that why don't you suggest optimization of tariff plans. If someone is say having a tariff plan of 599 rupee and getting a bill of 1000 rupee, then there is a mismatch between what plan they are taking and what bill they are getting at the end of it. Probably they're unhappy about it and hence leaving. So in that case, you will recommend optimizing their rate plans. So that could be some actionable insight to the business so that they can actually go and implement it. And finally, the question would come that, okay, I implement it, but how do I make it human-like solution? Because it is going to be all machine-based, right? Like we talked about example of credit card transaction approve or decline. Now they make a decision whether the transaction should be approved or declined by a machine, and you just get a slip, right? And where it is written the transaction is declined. There is no human interaction. But now in this case, when you need to recommend a rate plan to customer, ideally there should be some interaction between the customer and the company. And if you want to do it at scale, you may need to add some chatbots. Now those chatbots will not make or will actually deteriorate the experience if they are not making sense. So so you need to ensure that they also become intelligent over time, and they can do some self learning and can improve their performance. So that would be the part where cognitive analytics will come into picture. So there you need to leverage the artificial intelligence. Now if we talk about the opportunities, so at bottom we have seen what actions are supposed to be taken by a data analyst. But if we talk about the opportunity in all these areas, if you are working in descriptive analytics field, You should not just be creating reports manually. You should try to automate them as much as possible so that you can focus more on analyzing those reports. So hence the opportunity is automate. Now, how you do it, that you will learn obviously on the job. There are multiple tools, languages, the way you can automate such reports. When you are working on diagnostic analytics, the question comes, okay, I understand why did it happen, but how would a business stakeholder would understand? How would you communicate that? So you visualize the data first of all, and then show that summary to the stakeholder. Right? So here the opportunity lies in visualizing, summarizing the information. So you can apply a lot of visualization tools that are available in the market, or you can create your own algorithm. Thirdly, when you enter predictive analytics, then your focus area should be, how can I improve the accuracy of my predictions? I'm telling that by what probability a customer is going to stay back or leave, how accurately I can do it. Can I improve my models over time or not? Fourth one, when you're when you're prescribing the actions, when you're recommending the actions, then it is important that you start quantifying the business impact and then show it to your client or your organization, that if we do, or if you take these actions, if we do these steps, then what business impact we are going to get. And finally, when we are applying cognitive analytics using AI, machine learning, etc., where we are trying to interact with the customer through a machine, it is important that we keep on improving the experience. So Microsoft Cortana, Apple Siri, and other things, right? These are all examples of virtual assistant where they try to make it very convenient and easy for users to leverage them. So these are different areas, or I would say a value chain of analytics, which you should understand before you get into this field. Okay, uh, let's move to the next page. Okay, this one is basically the idea here is to let you know that you should not be bogged down by the idea that there are too many things to learn. There are multiple tracks of achieving things. So let's say when you're hungry, you have three options. Either you order food, or you assemble all the ingredients and then try to create something which is a quick way of doing it, or you do it in a very elaborative method and you do it yourself, right? You cook the food. In in all these three tracks, uh, I would say these are applicable when you are applying analytics as well, because when you are hungry for generating insights, you apply analytics. And then also there are parallel tracks for that. So the first one is, you leverage low or no coding platforms. So if you do not understand coding, you don't want to get into it, you can still get into analytics. You can still leverage some ready-made functions, libraries, etc., which can be used, right? A very good example is using Excel, right? So you don't need to know how to code the algorithm for creating a chart. You can just go insert a chart, right? So that's a simple way, and that's a very basic way. But there are very advanced analytics tools also which do not require any coding anymore. So that is track one. Track two is when you leverage the existing functions and libraries in different tools like R, Python, etc. Here you still need to know coding a bit. Some intermediate coding skills will be required, and you can upskill yourself over time to gain this knowledge. But it will be more like assembling all the ingredients of your food. Right? And the third one is when you create your own algorithm, where you feel that, okay, let me try to write my own algorithm so that I can solve this problem and I have more control on it. I can do hyperparameter tuning, as well as I can optimize the solution based on my objective functions and constraints. So in all these three cases, there's no preference. I say that all three tracks are very much uh, feasible, and you should not be thinking twice if you want to get into analytics, like how to get started. There are easy ways to get started if you go on track one, and then you can progress further to track three. But in all these three cases, I have also a piece of advice. So if you are ordering, then you choose your toppings wisely, which means that when you are also using some low no coding platforms, You should not be running wrong analysis. You need to have your basics right. So whatever analysis you're asking that platform to do for you, they should have meaning. So you need to choose your analysis, the statistical analysis, very wisely. If you go with the second track where you assemble all the ingredients and you use the existing libraries and functions, the idea is to add your secret sauce. Otherwise, this solution will not be, I would say, customized or uh, optimal for your particular problem or data set. So you may need to do some tweaks on top of it. Even after leveraging the existing functions and libraries, you would have to apply some additional layer on it so that you can generate the maximum value. And thirdly, when you are going with the full-fledged way of creating your own algorithm, then it is important that you keep evolving it. So you should not be just stopping at one point that okay, I'm done with it. In fact, you should try to see ways how you can keep on improving these algorithms over time. Of course, you cannot do it in one day, but over time, the idea is to keep on beating your previous milestone and improve your algorithm further. Okay, uh, now let's move to the next page. Okay, so now this is the path to become a data analyst. When we are in a situation, okay, we are just doing some course in the college, and now we're not sure how to get started. I would say choose your track, and this track is a function of the three things that we saw on the last page. Also, we have to keep in mind that it requires statistical knowledge, domain knowledge, and technology knowledge. So, whatever track you go with, first of all, choose your track and then acquire the missing skills. So, whatever skill you feel are missing, given now you know that you need communication skill, logical reasoning, data visualization, data extraction, you need to know statistics. So whatever you think is currently missing, try to start working on those things. You need to then pick the right business problem statement, because without objective, if you just keep on applying algorithms, probably you would learn how to apply analytics, but it will not give you an understanding how those algorithms are working, how they are benefiting the larger group. So after picking the right problem statement, you need to deep dive into the domain. So whether, let's say, it's for healthcare, insurance, banking, retail, media, whatever that vertical is, you need to go deeper into it, try to understand why it is happening. For example, when we talked about telecom industry, rate plan optimization, we need to understand why people are leaving. Unless and until we understand this particular industry, we won't be able to do justice to it. Then, after acquiring domain knowledge, we need to research about the right techniques to solve the given problem. So let's say the problem is about optimization. So then you need to look at all possible techniques that are available in literature, review them, see which is applicable in your problem statement and your data set, then apply accordingly. And at times you need to do experimentation. Right? There may not be a very easy answer after getting the problem statement. So you may need to experiment and explore. After identifying a different problem statement, one problem statement and their different techniques to solve for, then you need to apply the analytical frameworks. These frameworks could be like, say, prescriptive, predictive, diagnostic. So whatever is applicable in your case, you apply those frameworks. And once you are done with it, you need to upgrade and then choose your track again and keep on moving on that track. So over time, you will become a leader in data analyst field. That's what I believe. Because when I started off, I did not have any coding background, but over time, I've also learned it and I found it very easy now. That it's pretty easy to code and generate insights. Uh, so Suresh, this last page, if you can just move to the last one. Okay, so the idea here is that analytics is not industry agnostic. At times, people ask, uh, since when have you been in analytics industry? Right. So it's very loosely used. Analytics is not an industry. It's a field, but it's not an industry as such. There are industries like banking, retail, hospitality, etc., as you see on the page, but analytics can be applied anywhere and everywhere. So you need to understand that it's all pervasive and it's actually a service either to yourself, your organization, or to others when you're working in an analytics provider world where you try to solve problems for your clients. So it's a service and it's not an industry. Okay, so with that, I'll take a pause now, and that is all from my side. I'll be happy to answer any questions if you have.
Thank you, sir, for explaining this to us. If there are any doubts or questions, please feel free to open your mic and ask them, or you can put them in the chat box as well.
So Varun, I think it's been a very lucid presentation और आपने बहुत ही clarity दे दी है. And what I realize is that, every day, in our everyday life also, we are using data analytics, some way or the other.
Yeah.
So what are your prescriptions regarding, what kind of, so you've talked about certain kind of skills that would be required in terms of, learning some softwares or some kind of, programming or something. What's your prescription for that?
Right. So there are a bunch of open source tools available, and honestly, R and Python are extremely common now. So, and you can also get data on various websites, sanitized data. And if you just, ask students to learn R and Python, I think it will be very beneficial for them. It has like they have all kind of libraries and functions that can be used for analyzing the data.
Okay, and can they go into this field immediately after graduation, or would they require a post graduation, or are there any specific other kind of courses which can be done, especially related to data analytics field?
Right. So I think even the students may want to get into it. There has to be uh, job openings as well at the same side, right? So we need to ensure that there are companies that are okay to take folks after bachelor's degree, and we will find very few companies like that. Typically, the expectation is that either the person has done, say, post graduation in statistics or mathematics, operations research, or uh, or they have done some kind of a course on data science, which is going to add some knowledge. So such kind of session that like I have taken today, right? So there's a lot of information. It's very difficult to retain all this in like 1 hour. So there are courses that can be taken to actually do hands-on training on these concepts, and then it will make these students very much I would say in demand in market for data analytics field.
So you're talking about online courses?
Yes, there are a bunch of online courses. There are there are all kind of edtech companies these days that provide online courses.
Okay, okay. And how much time does it take to learn R or maybe Python?
So it
Although I
depends on
think it's individual to individual, but still.
yeah. Right. So in my mind, in 3 to 6 months, any individual will be able to develop good understanding of how to read the data, do some basic steps, and it's actually a matter of practice. The more you practice, the better you become. So there are multiple websites that also host data mining contests, and there are actually discussion forums on those websites, which also provide help. So you will see other participants talking about the data, the kind of algorithms they are creating, the features they are creating. So it is going to help. So there is a huge data analytics community outside, which is going to be very useful for any beginner.
Yeah, you have actually Even I know three D school people, seniors, and those are providing the training program for this Python and R, and SAS.
Right.
Varun, I have a question that why this Python and R become too popular? Is there any specific reason for that?
Yes, yes. So actually, I do a lot of work on SaaS as well.
Yeah.
And in my organization, SaaS used to be the bread and butter when I joined. But over time, what we have realized is that R and Python, first of all, are open source. So they are freely available to all kinds of folks. That has created a lot of, I would say, maturity in terms of their releases every now and then. Secondly, they offer bunch of machine learning libraries and functions. Right? When while some other tools, such libraries are very expensive. So even if you want to go and take licenses, it's going to cost you a lot. Hence, there's lot of popularity about R and Python. And lastly, these all these softwares can now be easily connected to various platforms. So if you, let's say, go for deploying your solution on cloud, there will be easy acceptability of any algorithm written in R or Python, or for that matter in any language.
Okay, so my understanding is that first, major thing is it is open source. If you go
Yes,
for paid software like SaaS, then it is huge cost for many things. And the another one is that because just like Windows or Android, everyone was were making their own software so comfortable that they can easily connect with these. That's why now people are making things which can be easily cooperate with the Python and R. So these two
absolutely.
things are majorly factors that are
Right,
become popular.
right. So just to add one more point here, so even SAS I think provides student license. So, and I'm not against SAS anyway. So I just want to mention that if people get a chance to use that, leverage it in some way, uh, then go for it as well. Because SAS is a language that provides a lot of procedures in a very systematic way. So, in case there's a possibility to use SAS, please learn that as well along with R and Python. It's going to only add value to your skill sets.
So, do you don't think that if we use SAS, then it will save our lots of time when specifically the economic student? I think for them it's not going for the too deep in the coding, and if SAS can provide a good platform for in a short form, and it already coded and in a short form, we can get our result what we want to get.
Yeah, no. So I think see all algorithms have their own, or not sorry, not algorithms, but the languages and software have their own pros and cons, and a lot of it also depends on which organization you're working for and what clients you're working for, what kind of platforms they are using. So let's say you learn a particular language and a different language is getting used in the real scenario, then you will have to learn that platform and language as well. So I think these things like languages, software, tools, these are just medium of arriving at the final thing. More focus should be on understanding the statistical techniques and then see how you can implement it through different languages.
Yeah, I think there are two students. One student is asking, uh, "Sir, are Google Analytics and Microsoft Azure certifies worth it?" There's some certification of this.
Yeah. So yes, yes, any kind of certification is going to add value, but I would say you also go through the content, like what kind of content they are offering, and even like Microsoft Azure. I think it's not just one certificate that is provided. They have a bunch of courses, and same is true for Amazon and other organizations. So there are a bunch of certifications, and these certifications have different specialities. So, for example, some would be very specific to the IT part of it. Some will be specific to data science part of it. So, depending on your area of interest and need, you can go ahead with them. But I mean, I would strongly suggest to invest in yourself. It's important that you keep investing into yourself and learn something new every year.
Yeah, one more. I think this is question is not normally economic student. Many students ask this question that if it's that girl Ritika see that Linden is saying that data analytics is dominated by the engineers. So even I know not only data analytics, even in the many other fields, you will find students will ask the question that engineers are doing but better in those fields. So why so this is asked. So I'm reading the proper question. LinkedIn has made me perceive that data analytics is a field of dominated by engineers. So as someone from economics background, how do we make an appropriate profile for the same?
Okay, so I feel it's actually a problem of plenty. There are lot many seats and students, hence students for engineering, and hence, I mean, I believe it's very fair for them to participate into it and then dominate, given there are too many. Right? For economic students or statistics students, you have an advantage. There's lower supply and hence higher demand, so you can differentiate yourself by focusing more on your statistical algorithm understanding. For example, you can provide that guidance what analysis is to be applied on what problem statement and what data set. So if you can uh, focus more on understanding the basics of statistics, even sometimes people miss out on probability kind of concepts. So it's important that you focus on those five fields that I talked about: descriptive, diagnostic, etc., and then pick one of them at least to start with and go deeper into it. So let's say you pick predictive analytics, then try to solve all kind of predictive problems that we talked about today: optimization, predicting something for future, estimating a value, classification problem. So if you solve the basics of all of these problems, I think you will be able to showcase in your resume and CV that these are the kind of problems you have solved for, and you can apply analytics anywhere.
So there's another question by Ayushi. For an analytics role, we are required to give a contest. So how do we prepare for that?
Sorry, can you come again? Uh,
Yes, sir.
hmm.
Ayushi is asking, for an analytics role, we are required to give a quant test. So how do we prepare for that?
Yeah, so that test is, I believe, done by multiple companies, and they basically check whether you are able to do data interpretation well or not. And this is just one way of checking your logical reasoning part, right? Even for say MBA entrance, there are a lot of quant and aptitude tests that people go with. There are a bunch of books that are available in the market, uh, and if there is a possibility to also get a sample of questions, you will get a better understanding of what kind of areas they are testing, and then you can accordingly prepare. So in my in my view, you need to know how to summarize the data, how to make sense out of it, right? So when you provide insights, they should be more meaningful and can be related to the business problem. So that way I would think about it, but I'm not sure what kind of tests they are doing, but that's my take on it.
Okay, sir. So the other question is by Tanishka. She's asking, kindly recommend any website or platform for data analysis to be learned right from basics.
Okay, so it's very difficult for me to particularly talk about a specific vendor or website. Uh, but yeah, I would say I started off with the data mining contest hosted by KDD and Kaggle. So if you want to go with that, that could be a good starting point. There you will have access to data and bunch of people to help you and discuss how to write algorithms, how to solve a particular problem.
Okay, sir. So Nandita is asking what kind of projects can we take up after completing the data analytics courses?
So we did discuss that today, the kind of problems that we solve, right? It could be in insurance, uh, let's say claim processing or estimating the value of premium. It could be a banking problem, as understanding whether a particular transaction is fraudulent or not. It can also be about assigning the credit limit to a customer once that customer gets onboarded. Uh, could be in healthcare. So there are so many industries, and as I said earlier, analytics is all pervasive. It can be applied in all industries. So it's very difficult to say exactly what project you will get. But if you want to do some self study, there are very popular data sets that are available, and you can start trying analytics on that. In fact, now, I mean, it has been there for quite some time, but there has been a lot of focus on unstructured data, NLP, the natural language processing, and computer vision are two very big areas which are emerging. So, structured data, definitely you need to understand and apply all these algorithms for prediction and forecasting. But for unstructured data, also, you may start looking at some data sets which can give you some basic understanding of how to process images, how to do text mining. So such projects typically give you an edge in terms of, I would say, the providing value to businesses. There's a lot of focus on NLP and computer vision these days.
Okay, sir. Um, if there are any other queries or questions, please do ask. And we have shared the
Varun, any
attendance.
idea about the compensation in this field? That
So let's discuss this offline. I'm not sure. I mean, I cannot talk about my organization's offers at this point, but definitely I can give you some idea in what range typically you expect business analyst to start, and then I can definitely help you on that.
okay. Okay, thank you so much for taking out time and giving this presentation and answering all the questions. Now, Maitri, could you please extend a formal vote of thanks to our speaker, Mr. Varun Agarwal?
Sure. Thank you so much, sir, for taking out your time from your busy schedule and conducting this insightful session for us. We are very sure that the students here present in the session right now have gained a lot uh, from your presentation, and they've definitely understood what kind of career prospects they have within data analytics. Thank you so much, sir, for coming and taking this session.
And thank you for making me part of this initiative. I really enjoyed it. I hope to keep interacting with you. All right.
Thank you, Varun. We might just trouble